Welcome again to Let's Talk Chemistry with Pastor Dan. We've been looking at emissions for the last few days, and we're talking about the fact that those are necessary to identify where electrons are at inside of an atom. So what we're going to do today is identify their placement. There's two different ways to do that. We're going to do the first one today, the one that's a little bit more rote. It's a little bit more cumbersome, but some people like it more because of the fact that you can easily see it. So in order to do this, you need a periodic chart. So I will post one in the notes over here. Let me make this a little bit smaller, and then I'll pull up the file that we're going to be using here. Oop, grab hold of that. All right, what's going on here? Up there. All right, and then we'll pop this up. So we're looking at electron configurations. Electron configurations is a way of determining the position of every electron in it. So we're going to identify every electron that we have. So in order to do that, there's two things we need. We need energy levels to be identified, something called orbitals. Now, energy levels are just simply the distance from the nucleus, how far the electrons are located, and there are up to 7 energy levels that we know of at this point inside of any atom. And orbitals are the placement inside of the energy. So we have to have different like wings in a hotel as far as where they get placed. So that's what the orbitals give us. So we're going to take our periodic chart. We're going to make some changes in it in order to make it more effective. So we're going to take helium here, and we're going to move it over here. So we're going to slide helium over here temporarily just for this process. And then we're going to put brackets. Now, I couldn't draw on this computer program very well, so I have a bracket over the first 2 columns, bracket over the last 6 columns, bracket over the middle 10, and a bracket for the bottom 2 down here. Now, for the top 2, we're going to make those S. For the middle 10, we'll make those D. And for the back 6, we'll make that P. And the bottom, these are the orbitals we talked about before, the placement inside of an energy level. Now, we've got to put the energy levels in it. So we're going to put, I forgot to put the little lines. We'll talk about in a second what we're going to do there. And then there's our energy levels, 1 to 7. But we have these 2 we have to identify as well. Those at 4 and 5. We'll explain how that happens in a second. So let's start with calcium. Now, if we look at our periodic chart, pull it over, calcium's right here. Calcium, 40 atomic mass, atomic number 20. Whenever we do electron configurations, we're always going to start at the beginning and finish where we're at. So we take calcium here, 40 over 20, and we start at the beginning, hydrogen, helium. Well, that's the first energy level, the s orbital, and there's 2 of those, so we say that's 1s2. Then we slide over here. The next number in the energy arrangement, we got 1, 2, 3, beryllium, lithium, beryllium. So that's in the second energy level. The s orbital, there are 2 there. That's 2s2. Then we keep going across. We have boron through neon. Boron through neon in the second energy level, the p orbital, and 1, 2, 3, 4, 5, 6, 2p6. Then we go over here, sodium, magnesium. Sodium, magnesium in the third energy level. S orbital, there's 2 of them, 3s2. Then we go over here to aluminum through argon. That's still in the third energy level. P orbital, there are 6 of them, so we say that's 3p6. And then potassium, calcium, 4th energy level, S orbital, there are 2 of them, 4s2. Now, there's a way to check to see if we did this right. We count all these numbers on top. We call these superscripts. As far as arranging where the electrons are located, add them up. 2 and 2 is 4, 6 is 10, 12, 18, 20. That's how many electrons we have. Remember, this is the atomic number of protons, but the number of protons is also equal to the number of electrons. So we have 20 here, we have 20 here. That's correct. All right, so let's do the next one. Next, we're going to do scandium. Now, scandium is just on the other side of calcium, but remember, there's a little line here, so something's going to happen. So we start at the beginning again, start hydrogen, helium. First energy level, s orbital, 2 of them, 1s2. Then boron through neon, that's second energy level, p orbital. Well, sorry, I forgot. Shoot, jump down here. Jumped across. Lithium, beryllium, 2s2. Then boron through neon, second energy level, p orbital, 6 of them, 2p6. Then we go down to sodium, magnesium, third energy level, s orbital, 2 of them, 3s2. Then aluminum to argon, third energy level, p orbital, 6 of them, 3p6. Potassium, calcium, where we were before, fourth energy level, s orbital, 4s2, then there's something called the octet rule. What is the octet rule? It's a rule that states the maximum number in the outer shell is 10. Look at so far. We have 2 and 6, that's 8. Sorry, maximum number is 8, not 10. What am I thinking? All right, 2 and 6 is 8. 2 and 6 is 8. So if I was to put all of these in my outer shell, I'd have 2 and 6 is 8 plus 10 more, 18. So I can't put them there. The maximum number of any atom can have in its outer shell is 8. So what we do for these, when we hit this d orbital, we can't put them on the outer shell, so we put them in an inner shell. We drop down. So when we hit this little line here into the d's, we drop down an energy level. So we go from 4 down to 3. The orbital's d, and scandium is the first one, so it's 3d1. And we count them up, 2, 4, 10, 12, 18, 20, 21. We got them all there. That's good to go. All right, let's do gallium. Gallium's just on the other side of that p orbital, that d orbital rather, starting the p's. So we start beginning, hydrogen, helium, 1s2. Then lithium, beryllium, 2s2. Then boron through neon, 2p6, same as doing before. Sodium, magnesium, 3s2. Aluminum through argon, 3p6. Potassium, calcium, 4s2. We hit the d, we drop down, and it's d, and we count across from scandium through zinc. That's 10 across there, so it's 3d10. We hit that line, what are we going to do? Well, you think about it, it makes sense. We're going to go back up. So we go back from the third back up to the fourth energy level, and we're just getting that 1 gallium. So it's 4p1, 2, 4, 10, 12, 16, 18, what was it? 2, 4, 10, 12, 18, 20, 30, 31. They're all there. All right, let's do the next one. Let's do silver. Now, silver is all the way over here. So we're going to go down the fifth energy level. So we're going to go all the way down to 5. And we're going to start with 1s2, hydrogen, helium. Then we're going to do lithium, beryllium again, 2s2. Boron through neon, 2p6. Sodium, magnesium, 3s2. Aluminum through argon, 3p6. Potassium through calcium, 4s2. Scandium through zinc, that's 3d10. Now we're going to do gallium all the way across to argon. There's in the back up in the fourth energy level, p orbital. There's 6 across there, 4p6. Now we're going to do, where we're at now, rubidium, strontium over here. That's in the fifth energy level, and it's the s orbital, and there are 2 of them. You're going to hit that d line again, so we're going to drop down again. We're in the fourth energy level, d orbital, iridium, stopping at silver. Silver's right there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 4d9. All right, now, last one we're going to try here. We're going to start all the way down to lanthanum. So we're going to go down to the 6th energy level. We're going to have that far to go. Start at the beginning, hydrogen, helium. Oh, what I did here is I just cut it, make it a little bit easier. We're at 3, 9. I'm going to finish out that one, complete that shell. So if we take all of those, all of that 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 3d, 5d, 5s2, 4d10, because we finished out, we're going to get at the other end there, indium. Indium is going to go all the way across to xenon, so that's going to be 5p6. Now that completes that shell. So we're going to do cesium and barium. Cesium, barium is in the 6th energy level, s orbital, and that's 6s2. And then lanthanum is dropping down again, 1 energy level, so it's 5d1. If you count those all up, I'm not going to do it for you. You can do that. We get 57 electrons. Good to go. Now, what do we do when we get into this sequence here, into these Fs? Well, let's do one. Europium. Okay, so europium, if you remember, here's our periodic chart. We start at the beginning all the way through, and I'm just going to take it down to the last filled shell again, where we were, 5d1. And now we're going to drop down here. Now, if we look over here, we see that the energy level is in the 4th. So we drop from 5d1. The next number, 57, is 58. So we're going to go from here to here. And it's going to be 6s2, no, we have 5d1, 4f6. How do we get that again? We look at 4th energy level, f orbital, 1, 2, 3, 4, 5, 6. And if we go, let's go back there, count those all up, you're going to have 63 electrons. Now you're going to say, what are we going to do when we come back up? Well, what we're going to come back up, we're going to do something interesting. All right, so let's go back to where we were before. We're going to complete that shell all the way across to 14. So we're here. Now I've got to come back up. You look here on our chart, we go 58 to 71. Hafnium up here is 72. And we want to go to gold, okay? So we're going to take our energy level all the way to that completed shell. Let's go back one. We have our 5D1, 4, 14. When I come back up, I'm going to cross that 5D1 out. Why? Because if I don't, I'm going to have too many electrons because I'm going to recombine them again. So now I count lithium again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Gold is 5D9. All right. Now what I want you to try to do, try actinium. Actinium's right over here on the periodic chart. Right there. Try to see if you can do that on your own. All right? Give it a shot. Pause the video. Hopefully you did. Here's the answer. Okay, so we end up with 5D1 cross out again, 4, 14, 5, 5D10, 6P6, 7S2, 5D1. Count them all up, with 89 electrons. All right, now, there's got to be a simpler way. Yes, there is. There is a shortcut method. So we're going to do those last three that we did, the long ones we did, as a shortcut method. All right, so let's take a look at my electron configurations. What am I doing here? Well, if I go back, and this is the last failed shell, and these are noble gases over here. Noble gases are complete. So we're going to put down XE. XE, if we find gold here, go up one level, all to the right. Xe is the last noble gas before gold. So we're going to put that one down. Atomic mass, atomic number. Then we start from there. Cesium, barium, 6s2. Lanthium, 5d1. And then we drop down the Fs. Cerium through europium, 4f6. 4f6. Now, is there a way to check this? Yeah. 54, the number of atomic number, number of protons, also number of electrons. 56, 57, 63. They add up. That's the shortcut method. All right, so let's take a look at our chart here for gold again. We're going to take all of this and make it what element? What element are we going to do? We're going to make it Xe again. I made a mistake there before. I apologize. And then we're going to start from there. So we're going to go 6s2, 5d1, drop down the 4 all the way across, 4, 14, come back up, we cross 5d1 out. Now I got to count to gold 5d9 like we did before. All right, try actinium on your own. See what you can do. Remember, we want to go last noble gas before. Actinium's right here, so last noble gas before. See what we come up with. All right, let's see if I can scroll that over. There we go. And get all of those there. If we do this, we get Rn 222 over 86, 7s2, 61. All right, now we need to practice these, so let's give it a shot. There's two long and two short method, so I want you to try to do those on your own. Pause it and see what comes up with. All right? All right, here's the answers. All right, hopefully that wasn't too bad. We will practice these tomorrow before we learn a new process, which is faster but a little more cerebral, so you have to think. Hopefully that wasn't too bad. Take care. God bless. Have an awesome day. Bye.